Okay guys, thanks for watching again. Last video we focused on building the device itself physically, like the wires and the buttons, and in this video I will show you how we're gonna actually code the software to run our flight control inputs. So what we first need is the Arduino IDE. It can be found on their own website. I will also link it in the description below so you don't have to go look for it. You can just download the version you need. If you use Linux, you just use Linux, Mac, Windows, whatever. Just download it and run. And then it will look like this, and it's pretty straightforward. It's also just called Arduino on your PC. So if you can't find it, and it will open a new sketch for you. Besides the IDE, we also need a library. And if you want to know what a library is, it's a piece of code that somebody else has written, but it will take away most of the work that we have to do. So instead that you have to build the entire functionality of, let's say, the gamepad we're going to use, you only have to tell the library, like, I pressed this button, I released this button, and sent this to my PC. So that will take away a lot of the work. And I think perhaps if you're just starting out, it would also just, the learning curve would be too high if you would build it yourself. So if you want to download this, you can just click on code on the green box, download zip. It will download to your PC. That's speaks for itself. And if you open the Arduino IDE, you go to Sketch, include library, and add.zip library. Open your file browser. You just select the library you just downloaded and click open. Of course, I already have this one installed because I already made an Arduino project. So all we have to do then is go to Sketch, include library, and then click on the HID project. As we can see, we've got it now included in the header, and this means that whatever code we write, so if we would write something completely else, these files will also get included, or the code behind it, in our program. So your code will still look clean because it's not filled with all their boilerplate code. It's just 2 lines, but for the system it will receive all the necessary information it needs. So let's get started. We have 2 blocks. We have the loop and we have the setup. The setup block is a block that will execute once your Arduino starts up. So it only gets executed once or twice if you replug it, whatever. And the loop gets executed constantly. So this is where we usually declare things like input A is a button, input B is this, etc. And in the loop part is where we will tell the system, okay, this is what you constantly need to do. So in our case, it will be something like you constantly need to check if a toggle is on or off and press the corresponding gamepad buttons and send them to your PC. And that's pretty much it. And as we have a look at what we've actually built in the last video, we'll see our toggles. We have the LEDs. We've made a design choice to have the LEDs hooked up to the toggle, so they will always be on or off depending on the toggle state. It could also be a choice to also wire them to the board, but that would only take up more slots. And in this case, I would like to have more buttons than I would like to have more LEDs. So if you just wire them in here, you just save some space on your board. But if we take a look at what is happening, is that the board is providing power, the toggle goes on, power goes back to the board. But this white cable and this white cable we've actually installed to check if the power was on or off, as we've mentioned in the previous video. So how are we going to do that? Well, let's first start off by, let's just make an art piece of it, but let's see. our first toggle, like the white wire, goes into 0. And the second toggle, bit wiggly, goes into the first pinhole. So what does this mean for us? We'll open a sketch. We're gonna first define our first input. So input A is 0. We'll tell the system it's an int, which means it's a whole number. So 0, 1, 2, etc. And that's because if we take a look at our system, there never will be a 0.5, 1.5. It's always a whole number. So we just use an int. It's short for integer. You also have doubles and floats. You need those if you actually need decimals, but in our case we don't need those. So we do the same for input B is 1. And it's the naming is something I just personally made up. You can call it button A, button B, button 1, button 2. That's totally up to you, as long as it's connected, so you can't do this is not possible. Okay. So, input A. Now we have a pin mode in our setup block. And what does a pin mode mean? It will tell our system, okay, input A, what's input A? It's an input. And this is to make sure that our system knows that pin number 0 is always an input. So it never has to send something out, only data comes in. Let's go back to our code. And we do the same for input B. If I'm going too fast or you have trouble following along, just pause it every time you have to input something, just to make sure that you understand what is happening. And I think that's the most important part than finishing fast. So I will also put all the code in the description down below, so you don't have to worry if you missed something or you want to read up on what I've done on a later time point. So as you can see, input A is an input, and we ourselves have declared that input A is nothing more than the number 0. So we could also do this. Pin 0 is an input and pin 1 is an input. But as let's say we also need to do something here. 0 is on. This is not real code, it's just an example. And we later on decide, okay, I want to change this to pin 3, because that's where the cable will be and it's easier to route. Then you have to change it on 3 spots. And then if you forget one, you can look through all your code where something's going wrong, because you don't get the results you expected. So you can just do pin inputs A, and now our system knows, okay, input A is 3, and if you do it input A, now our system also knows that here we are referring to the 3 we defined on top. So it's just to make your code more maintainable. Later on, if you come back to your code and you're like, okay, I just want to change one simple thing, you have to change it in one place and not on 20 places, or even worse, in 100 places if you have really complicated code. In this case, it's quite a simple code we're going to write, so it's not that big of an issue, but just to be... It's better to learn good habits than to forget the bad ones. So we have our pin modes and we have a gamepad. Begin. Here we tell that once the program starts, we have to initiate a gamepad, and in our library you will find a code that says begin. You can't see it because it's in the header file, but we know it's a class that's a code block that gets executed, just like this void loop, by the brackets at the end of the begin. So we know that Okay, gamepad is listening and now it needs to start. So in this code, everything is included to make the gamepad start. There's nothing we have to do ourselves about it. So now we have everything defined. We have our 2 buttons. The gamepad needs to begin. And now we need to tell the system what needs to happen once it starts receiving data. So what are we going to do? We're going to say if. So if something, and we need to declare what if is in these brackets. Digital read. Now we need to tell him, we need to tell the system, okay, what are we going to read? We're going to read input A. And if what is output input A? Well, if it's on. Close it. So what we just did is tell the system if digital read input A, so pin 0 in this case, is high. So what will happen is that our system will check if the power will be going through pin 0. And if the power is high, so if it's on, we need to do something. And something is declared by these. So that will make it a bit clearer for you. Between these squiggly brackets. I'm not quite sure what they're called, sorry. So what do we need to do if the input is high? Well, we have a gamepad. We press a button, right? 1. And we have input B. So once again, we read input B to see if it's high. Gamepad.press 2. And in Windows, you have 30 buttons you can program for a gamepad. So you can just pick a number you'd like. If you would personally like, for some reason, that this is gamepad number 3, that's also possible. And I will show you now how that will look in our system. So if we go to, let's see, hardware and sounds, devices and printers. My laptop is in my native language, so devices and printers is what it's called in English, I believe. Hook up our Arduino. Oh, wrong one. Arduino. We can see that 1 is on and 2 is on. Upload the code. Yeah, both buttons are on. Oh, needs to reconnect. But what happens if we turn the buttons off? Well, you can't see it, but I'm turning my buttons on and off. But the state still says that 1 is on and 2 is on and nothing else. And that's because we haven't declared what to do. Digital read input A if it's low. So right now our system, if we just follow the logic, says press button 1, and if input B is on, press button 2. And it will keep pressing until we tell it to stop. So we actually forgot to write gamepad.write. So this will send the data actually to our system. Apparently I already had that installed on my Arduino, so that was my mistake, but you need to include this in the end. So just to follow along how this code now starts running, if it's high, we press 1, then it exits this block, and it checks if it's low. Well, we haven't put anything here yet. Then it goes to check if it's B, do this, and then we write it to the system. So we always write, but we don't always press the buttons, just depending on the if statements and if it's true or false. So if it's low, we do gamepad.release, right? Button 1. And the same we will go for if digital read input B is equal to low. We do gamepad.release 2. We press it. If it's not on, we release it, vice versa. Now let's see how this looks on our system. So it's still uploading. So 1 is on. Oh, okay, apparently I got the second toggle, but as you can see, those are working. And last but not least, toggle 1. It's a bit tangled up here in the wires, but here we go. So that's working. We could actually already use this if we wanted to. We're gonna make it a little bit better to use in games. So let's see how we're gonna do that. But I forgot to mention, I do it on autopilot, but the upload button can be found up here. Before you upload, you can also click the verify button, and then the system will check, okay, what you've written, is it actually valid code? So if I would do gpad.pers equals go, here we go, and we do verify. Look, the system will actually tell us what we've did wrong. So gpad, the system has no clue what a gpad is. We never said anything. And if you would declare a gpad somewhere, so let's say in gpad is 0, and then the system will tell you, okay, but what's PRSS, etc. So that's a good way to check if your code is valid before you upload it. If you upload it with the errors in the code, gpad is whatever, and you press upload. Oh, wrong button. Upload. It will also do the verification first, so you don't have to worry that you're gonna send faulty code to your Arduino, because you always have a safety net to stop you. Okay, so if it's high, press. If it's low, release. Now, let's see if we go look at our game. Okay, I'm not gonna wait around to look at the game, but we have on and off states, right? So we have a button to turn it on, gamepad 1, and we want to bind a button to turn it off. But right now we don't have a button to turn it off because it's just a button that gets released. So what we're gonna do is actually, if the button doesn't get any power, we press 11. You might wonder why 11. Well, if the first toggle is on, we press 1. If it's off, we press 11. And I'm going to choose 11 because it's easier to have a constant system like 1, 11, 2, 12, 3, 13, 4, 14. And then you can just go up to 10 and still have enough room to assign all the buttons and have a logical system with the naming. It's just something personal preference. But that means if the gamepad is on with the first toggle, we also need to release the button 11. And the same goes for gamepad.release 12 for the second toggle, and gamepad.press 12. What will happen now is that if it's on, we have 1, if it's off, we have 11, 1 gets released, and the second toggle, if it's on, it's 2, if it's off, it's 12, and the 2 or the 12 gets released depending on the state. And that will give us a whole new set of possibilities. As you can see, 1 and 2. 1 and 12, and 11 and 12. And if we turn them off, or on actually. See? So we switch between 11 and 1. And there's always a state selected in this case. So that's actually what we are aiming for. So let's see how this will translate in game. So I finally managed to load up the game. It takes ages, but whatever. And I've jumped directly into the menu to go to the control section. As you can see, our Arduino is actually instantly recognized by the system, also what type it is. And we're able to start assigning keys. So what I've went with in this demonstration is to go with the cabin lights, just because it's easy to see if they're on or off, and we can see how our buttons operate. So on the off state, 11, cabin lights on, 1, panel lights off, 12, panel lights on, 2. So that would mean that if our switch alternates between states, they get switched instantly. So let's see how this looks in game, shall we? Let's make it night so we can actually see if the lights are working. Here we go. And let's do the first toggle. I think this was the first one, but yeah, cabin lights. So, this one is working quite snappy. And our overhead panel. So as you can see, that's exactly what was expected. So we've got the toggles wired up now. We've got the code running. And our game recognizes the system and the inputs. Now, if you would wire up 10 buttons, for instance, you might get lost on what input is which button. So you can just clear the inputs. And if you switch the toggle, it will tell you which button it is. And if you accidentally turn it on while you have to turn it off, you can just keep the logic in mind that 11, so on is 1, or the other way around, just how you set it up. So that's the in-game version. I will show you quickly our code again, just to tidy things up. We have our gamepad A, input B. That's all working fine, gamepad.write. But let's say you've bought 10 buttons. For instance, we can just do the same thing over and over again. So you can just rinse and repeat. Input C is an input. Okay, fine. Input C. So input C is perhaps in pin 2. Okay, and then we can just repeat these blocks. Input C. Oh, capital C. And then 3, 13, 3, and 13, etc. And D is 4, 14. Don't forget to initiate it here. Input D is 3, but you get the point. That's up to you, how many you like, how many you have available, how many space you still have on your board or in your design that you have in mind. Because once again, I can show you how to code, I can show you how to wire it up, but like the woodworking part, I think everyone is on the same level as me, or better, because you can't be worse than me. And that's our project done. If you have any questions or suggestions, you can just leave them down below, and I'll try to see if I can answer them. And I'm going to start working on my radio units. So thanks for watching and have a nice day.